Okay, so up next, presenting effective governance for continuous security in hardware devices, we have Arun, Prabhakar, and Purnima Bihari from Security Compass. Arun and Purnima, you can take it from here.
Good morning, everybody. Thank you for joining us today and providing us this opportunity to share some of our thoughts and experiences about a topic that's of special interest to both of us. Hi, I'm Purnima. I'm a senior product manager and I work on building product features that automate security processes. And I'm joined today by my colleague Arun, who specializes in product security architecture and helps customers implement optimal DevSecOps practices in their organizations. So, before we start today with the heavy loaded topic about what a governance model is and why you should care, next slide. I wanted you to think about building a house. Next. Okay, so what all comes to your mind when you think about building one? Construction, vendors, budget, timelines, landscaping, nuts and bolts. So you can see there are a lot of complicated moving parts. Now, let's say I present to you two teams to handle this job. Next slide. Uh, can we click through twice? Perfect. Okay, so now let's say I present to you two teams to handle this job. One, where there is no clear owner or no clear direction on who should be doing what, versus a team which is super organized and has very well defined rules and responsibilities. Even without asking, most of us would choose the second option because it immediately instills a degree of trust in the end product. You know it'll be secure. You know that any interruptions or unexpected outcomes would be handled professionally and properly. Accountability and transparency are the foundational blocks of any successful project development. Hardware security is no different. Next slide. There is a complicated supply chain. There are loads of threats and vulnerabilities that might be exposed if the right teams are not deployed at the right moment. A good governance model is what differentiates and sets up the right team at the right places. A good governance model allows the team to structure itself to effectively identify, monitor, and mitigate risk in an iterative, continuous way as the team or the product scales. A good governance model is the glue that ties all these moving parts in a cohesive and coherent way so you can embed security right into the design phases of your hardware. Hardware applications, there are two major categories. Next, there are two major categories that we come across all industries. One, where the hardware device is used as a standalone device, and another where it's embedded as a part of a bigger product. The categorization of hardware devices influences the threat landscape and overall approach and cost of fixing hardware vulnerabilities. Unlike software, hardware vulnerabilities are way trickier and way more expensive to fix after production. While a lot of focus is lent to the software that runs on the hardware, hardware remains an ignored aspect of overall security of the system. Thus, when we consider hardware security, there are two aspects to consider. First, the security of the hardware itself, and second, how does the secure hardware enable the software that runs on it? Unchecked, these unresolved faults in the system are a major threat. And if you look at the rate of IoT adoption itself in the next decade, we are staring at an abyss of unbalanced security versus adoption measures. There is a huge cybersecurity storm just waiting to happen. As you see, there's an urgent need to find better and more efficient ways to handle this aspect of security. And why, if you're a security executive, a program manager, or a process consultant, you need to start thinking about setting up the right governance model as the foundation of your company's secure future. Now, I would like to pass the baton on to Arun as he will walk us through how we can go about accomplishing continuous security in hardware modules.
That was a good intro, Purnima, and thank you for setting the context. But before we get into discussing these details, let us share with you on what these hardware devices are and the typical applications of these devices. So today we live in a world of Internet of Things. There are so many applications of these, the Internet of Medical Things, the vehicular IoT, or for that matter, the smart home or smart industry applications that make use of a lot of these devices. But the one most common device that is observed in all of these applications is the use of SOC. SOC, or the system on chip, is an integrated circuit that integrates most components of the electronic systems. And some of the figures that you see here, be it the microcontroller, the Arduino, or the microprocessor, or for that matter, the ASIC or FPGA kind of integrated circuits, you will notice that a system on chip could be either built around them or is involved in integrating multiple components. And the reason why we are particularly talking about the SOC in our session today is not only because of its use in applications, but also the SOC supply chain is highly vulnerable to many attacks. And the intent of any security leader is to address and mitigate these security risks. All right, so this is a common problem, the functionality versus security. From a functionality perspective, if you see, the devices that we use today have evolved a lot to perform many aspects, including data storage, better computing, the connectivity has improved. It helps from a mobility, usability perspective, why even the accessibility aspect has got better. But with regards to the security of all these features, it still remains to be an afterthought. In fact, I would say that the security has been thought through, but just that it has not been practiced rigorously throughout the device lifecycle. This results in a lot of threats being exploited. And that brings us to the next slide. We'll quickly understand about the threat landscape of these hardware devices. Here we got the picture of a microcontroller-based system on chip with several components. Of course, one can use the system on chip or the SOC for many applications. But what is interesting to see here are the security threats. Again, this is just a snapshot, but what you see here are the different threats that could be successfully exploited. I'm not going to go over all of them, but since we talked about the functionality versus security problem in our previous slide, let's take one of these threats, say the insecure JTAG access, which is the last bullet that you see here in the slide. As some of you know, JTAG interfaces are used for debugging purpose, like debugging different files, debugging the binaries, accessing all the chips on board. So quite a lot of benefits from the JTAG functionality. But one of the common security recommendation that is mostly not followed is that this JTAG interface should not be enabled in production and is only meant for development and testing. But having this enabled makes it an easier entry point for hackers. And this is a real-time scenario that I've come across in my past life when working on an IoT device assessment. So what we observe is that the functionality is well thought of, but the security is not properly planned, which is exactly what we were talking about in the previous slide. And this is interesting to understand how the threats get exploited. And that's where you see the attack types. Quickly, without getting into too much details, at first, the invasive attack. Here, the threat actors have a direct access to the system and modifies the physical properties of the system on chip. On the other end, the non-invasive attack is a more passive one, not requiring any physical access to the system. And that leads us to the other interesting part to understand how the threat actors exploit all the security threats that you see over here. To understand the different type of threat agents or threat actors, we may have to understand a bit about the different stages of the system on chip supply chain lifecycle. So that will help us understand the different people who might introduce or exploit the threats. The different stages includes the internal, external teams, design teams, the professionals working on synthesis, verification, foundry manufacturing phases, and there are packagers and people who sell it. So now you see that the rogue elements could be inserted anywhere during the life cycle, including some of the insider threat possibilities, right? All right, so that brings us to some important questions. How to plan the security for these devices? Now, the short answer involves rolling out a security program. And the security program will guide us in a lot of ways, importantly in implementing the concept of continuous security throughout the life cycle. So let's see in the next slide what exactly and how exactly that's going to be achieved. What we see in front of us is a very generic life cycle of the hardware devices. Considering the variety of integrated circuits and devices that are developed and the applications of them, we have come across the generic phase names. So let's get into the details and look at the capabilities of the hardware teams working on the different phases of the life cycle, including the security activities that are performed here. All right, it all begins with identifying the need and the development of a business case, and that's exactly the sole purpose of the ideation phase, which is the first phase. But as we move on to the planning phase, this is the phase from where a lot of team involvement happens. Many of the strategies planned and the executions are being done. The phase where you get the approvals, identification of vendors, and so many other planning activities happen, including the planning of resources and logistics. All right. In the architecture phase, as one could see, there are a lot of requirements being defined. The functional requirements, the safety requirements. Secondly, mapping all the assumptions together and conceptualizing the whole idea to better define how the whole product would work. This involves a lot of brainstorming, whiteboarding, discussion with internal, external teams, and so on. When you look at the security team's activities, their work involves gathering all the security, privacy, regulatory requirements that are appropriate for the device developed. There are architectural reviews performed that look at the holistic picture, including the integrating electronic components. The third-party components as well, of course, to determine the integrity level to address the failure modes of these devices. Then comes the design, where the architect's intent is to build the non-functional prototypes. They are developed using simulators or emulators, using electronic design automation tools for simulating chip designs and integrating electronic components to the circuit. It is important to note that one of the key activities done in the design stage is the pre-silicon verification. This is primarily done to check the correctness of the hardware module design so that the functional bugs could be detected on time. If that is what the functional teams do, the security teams focus on a similar set of proactive activities, one of them being threat modeling, an activity that is loved by many taking the shift left approach in system development. This is a heavy topic by itself, but briefly speaking, the focus here is on understanding many aspects, including the potential entry points, the adversarial goals, and how they are all tied to the internal structure of the integrated circuit. All right, with regards to the engineering phase, the functional prototypes are developed, including the core features of the product. And of course, there is a continuous effort to test these prototypes with selected users and gather their valuable feedback. That will help you improve the overall reliability of the product. And the security team focuses on an important activity, which is the component analysis. Keep in mind, there are lots of open source and third-party tools that are being used throughout the SOC supply chain. The benefits they bring could help the functionality of the devices, but the risk they bring should not be a threat. So the component analysis focus on addressing many of these aspects and managing the risk effectively. Finally, in the validation phase, the post-silicon validation is performed here on fully functional hardware prototypes in a real-time environment. Now, this is considered as a mandatory step before the mass manufacturing phase happens. Of course, at this stage, the security team does a lot of pen testing and complaint reviews on the complete product. Now, the product is launched. Now, the important point to note here is that the hardware development should be an iterative process. You will notice that the prototype development happening at multiple phases like the design and engineering phase, the non-functional prototypes and the functional prototypes. That's what I mean. And it should be verified time and again based on the feedback received, right? So one thing that you note over here is that we have highlighted those phases from architecture to validation where the iterative process is observed. And you see that there is a bidirectional flow involved over here. Accordingly, the security mechanism is also repeated in an iterative way. Over to you, Purnima.
All right. So now that we've discussed how continuous security can be accomplished in a hardware development cycle, your next question would be, so how do I get started? I'm interested. How do I go about designing and establishing a governance structure? What do these building blocks look like? Well, to find a solution, we first need to define the problem. So we need to define what are these gaps that introduce these hardware vulnerabilities from a function operational perspective. So broadly speaking, they would be probably be divided into four categories. The first would be philosophical. Now, when I say philosophical, it means the general awareness or the general culture within the organizations towards security. So, is security considered like a necessary evil, or we have to do it? It's not something we want to, but we have to. Or is it an integrated part of your business delivery system? The philosophical gaps actually affect how resources get allocated and whether there's effective executive sponsorship to take this initiative ahead when it comes to it, right? Then people. An understanding of what governance model needs would get you a better understanding of what's the talent and skills you need to make it successful. So, not having a clear understanding of who are these people we are looking for and what kind of leadership do we need to be leading this initiative, there's a general inefficiency that's introduced into the process, right? Uh, Next is process itself. Now, any successful implementation, any successful security or otherwise implementation needs a lot of collaboration and communication mechanisms. You need to have the right and the most effective communication collaboration, because it's not just enough to have the right team at the right place. They need to know how to approach when, let's say, an incident happens, right? Like, what does your incident response looks like? Um, if there's a lack of it, you're basically doing a lot of development in silos. So you're kind of starting to introduce a lot of incompatible interfaces. So it starts being a bigger problem, especially in hardware development, because there's it's such a complex supply chain. Not having the right process definitely hampers your overall development and security. And lastly, technology. Now you have, like, what do you know, what tools are you going to use for the detection, mitigation, monitoring of risk? uh, it not having the right tools, not having the right tooling budget actually introduces a plethora of problems down the line. And lack of automation actually introduces delays in the actual production timeline, because you might think it's security that's hampering your delivery timelines. It might actually be there is not enough automation coverage to go around it, right? So while the governance model does not close all the gaps, it does render itself uh, effective in closing the gaps on the people and process side, which in turn help tide over the challenges on the philosophical, technological side. But when we talk about a governance model, essentially we are talking about the people and processes that are involved in it. Next slide. So once we know what a governance model, let's talk about the actual three pillars of governance model. Okay, so what are these three pillars of governance model? Now, the basic of any strategy is you need to have the right vision. You need to know how you want it to look at the end of the day, right? So the vision of a security governance model for hardware security would be implementation. It should help you implement, it should help you maintain your governance framework. It should make sure that you're meeting your security strategies, but those security strategies are well aligned with your business objectives, and they're consistent with whatever regulations or laws or any policies that are relevant to your industry are being followed. So you are providing assignment of responsibility to manage the risk that comes during this process. What would be a strategy? Well, the first thing you want to do is you want to start figuring out what are the different components of this governance model. Who's going to enable it, or who or what is going to enable or act like a catalyst, and what are my obstacles or roadblocks going to look like? Then you go about figuring out, okay, what is this culture? It's a process change. Any process is only successful as much as the culture that actually adopts it, right? So how would you implement and maintain this culture change? And then as you go and progress. Now, the only way I can make sure that this process sticks and is successful is if I can constantly measure my performance and tweak it iteratively, right? So, your three main objectives at the end of the day, which are driven by your vision, is first, in simple terms, you have the right managerial, you have the right leadership vision behind it, you need the right sponsorship. Compliance, you're meeting all your compliance obligations, you're not spending a lot of money or time into it. Over time, it's something that becomes secondary to your nature. Alignment, there's pure alignment between your security objectives and your business strategic objectives. A misalignment definitely does not work or bode well for either of the teams involved. uh, Next slide. So now looking at what are these components of the governance model, right? Because I talked about like, well, that was the pillar. I have a vision, I have a strategy. Now, what goes into it? Defined roles and responsibilities, having the right team, having the right skill, everybody knowing what they wanted, what they should be doing, or what they want to do is a main piece of the puzzle. You have to have defined roles and responsibilities. Transparency and accountability. Well, if you're talking about compliance regulations and you're talking about audit agencies, you always have to have the right documentation and evidence, and even the right accountable people and the right access, so everybody knows what's happening, but you're also keeping everybody true to their word. You want to have everything clear and accountable. So if anything goes bad, you know where to go. If anything goes wrong, you know where to go, right? Then having a really good knowledge and a good research, the policies and regulatory framework which are relevant to your industry. So having a repository of it or having kind of a team which looks into it continuously is a very good foundational piece of this governance model. And the last two, risk and performance management and monitoring and internal tools, I actually consider them as slightly different levels of maturity. So if you're at, let's say you're at a stage where you can start monitoring, monitoring is the base of how you would do risk and performance management. So you monitor and you can finally like do a little bit of analysis, and then you go into like, what are these risks that I come across on a continuous basis? How can I reduce my risk posture? How can I improve my performance? So overall, together they give you a good, complete security governance model. O-
All
Over to
right.
you.
Okay, so Purnima talked about the several aspects of the governance mechanism. Importantly, the pillars of governance and the components of governance. But there are broad questions that emerge. How the strategic elements of the governance model get rolled out in the security program, sorry. Second, how the components of the governance model are going to be successfully accomplished in the security program. Now, the short answer for both of them is organizing your security teams and assigning them the right roles and responsibilities. If that is in place, many aspects like the risk, the regulations, internal controls, and all of these, which Purnima was just talking about, all of these could be accomplished. All right, so that takes us into the next slide to answer some of these how questions that we just asked. Color coding of InfoSec teams. I'm sure some of you must have come across this concept through different blogs or articles, an idea that was introduced a couple of years ago, and since then, many researchers have extended this to suit to the current trends in information security. But what this figure essentially conveys, you see that the security teams are being assigned to different colors, which is more of a visual representation to see how the responsibilities and accountabilities within the InfoSec organization could be planned. Now let's understand further about this. We have the primary and the secondary roles. Who are the primary roles? They are the builders, defenders, and attackers. The builders are represented as the LO teams, which are the product team that build the complete product. For example, the ones who do the schematic capture of an IC or designing the integrated circuit. The defenders are also called the blue teams, and their primary job role includes implementing the defenses, working on the code reviews, and mitigating the risk identified. The attackers, or they are called the red teams, and their primary job role includes physical attack assessments, doing vulnerability first testing, and learning new attack techniques. Okay, so that's the primary team colors. Now, what are these secondary colors for? Basically, these act as the interface to the primary teams. We are talking about the orange, green, the purple, and white as the secondary teams. So basically, these act as the interface to the primary teams. And for our discussion on the team structure, we'll only focus on the purple and the white teams. Now, we are also calling them as the security champion. The two teams, purple and white, play a key role in the ongoing engagement, primarily to satisfy many elements of the governance mechanism. And we will see how that comes up in the next slide. But lastly, keep in mind, all these are conceptual models. Giving a team a specific color is not how it happens in matured organizations. Maybe the red team exists, maybe the blue team or the purple team does, but the color coding does not really matters. And what really matters is the cultural transformation, which encompasses organizing accountable roles in the security practice, assigning the right responsibilities, and those are more important than a conceptual model having different colors. Now, before we move on to the next slide, a few questions. How is that we are going to consume this type of a team structure proposed by the security researchers for assigning accountabilities to the security champions that we identified? And importantly, how is the continuous security going to be achieved by the security champions? Okay, security champions. First, let's define the security champions. They are the ones who empower and enable all members of the security practice to learn, adopt, and make sure all security risks are being mitigated and all the security rules are being followed throughout the engagement. Of course, they make critical decisions about the security risk and communicate effectively to the organization management to improve the overall security posture, I can say. Okay, so we identified the purple and white team as security champions. Let us see in detail what their responsibilities are and how they contribute to the overall governance. White teamers, who are they? Some of you, the security directors and the product owners. And yes, they play a functional role, strategizing events to foster better collaboration among all security teams, and that includes the product and business teams as well. In fact, it includes the vendors and partners in all strategic security related aspects. And you get to see the team functions here, auditing the security posture of the whole product, right from the inception stages to the product launch, planning the complete process steps, since you have different types of ICs integrating with different devices, coordinating among all security teams because there are so many players involved in the entire device supply chain, taking accountability of action. Well, that's a pure leadership quality, and that helps the security in very many ways, and you know that. Purple teamers, who are they? Many of the consultants, especially the people working in the capacity of DevSecOps, I can say. As you could see, they play a technical role that act as bridge builders, primarily between the defensive and offensive teams, which could be internal and external to the organization. And you see here the team functions or their responsibilities, be it the due diligence by performing the right security activities throughout the entire life cycle of the device, or defining the security validation strategy based on the device type. It could be your FPGA or integrated circuits like ASIC. Planning the security testing methodology as per the device architecture requirement, which helps determine the level of trustability of any device. Cost benefit trade off for the defense plan. For example, a defense mechanism plant might improve the integrity but not the performance of the device. So a balanced decision need to be taken. Okay, now how are these security champions going to help achieve continuous security? And there you go. So all these terms that you see here are very specific to a strategic role of a white teamer. So a white teamer playing the role of a security champion brings a lot of value to the security program, especially the collaboration with different teams, monitoring the ongoing compliance, and by practicing continuous management, things like tracking your budget, the resource requirements of the security teams, and so on. And when it comes to the purple teamers, the benefits that you see are more aligned at an executional level. performing continuous monitoring. That is a constant monitoring of threats throughout the semiconductor supply chain. And when it comes to conduct continuous reviews, there is a lot of work. That could be secure design reviews, secure code reviews, secure configuration reviews. We saw some of them when we discussed in in one of the previous slides. The purple teamer needs to organize all of these. But what we see here is that the champion's role is continuous throughout the life cycle in securing the devices. And here we see that both the security champions, purple and white teamers, complementing each other to build a security program from both strategic and executional aspects. And here we are arriving at the fact that a strong security program will help us accomplish a strong governance model. Okay, we have talked a lot about the conceptual things like the white team, the purple team, but how does all of these come into effect, especially in a huge program where there are a lot of teams? That's going to be the focus next. All right, but before we go into the details of the slide, remember one thing, that the devices are not standalone when it comes to solutions. They are going to be embedded with a software component or a mobile application, making them an IoT or smart solution. Because of this, the security champions have more interactions with other teams throughout the organization, right? So for our understanding in this slide, we will consider an example scenario of how the security champion comes into effect in establishing a security program for continuously securing the IoT solutions. Since we are talking about very many teams and roles throughout the organization, we thought of categorizing the different teams in the enterprises into the following four divisions that you see over here: the business, the operations, the security and support divisions. And we are going to see how the security champion are going to interact with the different teams in the division that we have identified. So it all begins with the product teams defining the business case and their expectations for every stakeholder, including the security teams. That is when the security champion should chalk out the high level security requirements, get the financial assistance from the investors for rolling out the security program. The security champion also gets the support of business leads, including the business analyst, product architects, and domain experts, and also works with a lot of vendors and suppliers to establish the timely availability of the relevant hardware devices. Okay, from an operation perspective, specifically for a cyber physical solution embedded with a lot of hardware devices, there are so many teams and competencies, and the security champion continues to play the strategic role. Many of the components of the governance model, including the risk and performance management, will have to be planned along with the operations team by the security champion. So this includes working with the compliance managers, risk officers, IS auditors, and of course, there are other roles too. The security champion must also work with the legal teams so as to be prepared for any kind of legal ramifications. All right, when it comes to the support teams, security champion at this phase works with the QA leads and program managers to help identify and improve the quality of outcome of device verifications. Also establishes the complete transparency on the functional bugs that exist in the system. And importantly, the security champion also works closely with the physical security teams and the facility managers so as to be being prepared for a device failure and ensure continuity in the ongoing operations. And finally, the security teams, when we talk about IoT or embedded solutions, the applications and infrastructure will have to be security tested too, along with the device security. And a comprehensive security analysis is required for a foolproof working of the devices. So the security champion has a lot of interaction with roles like crypt analysts, AppSec engineers, IoT security specialists to effectively remediate the risk and to monitor the controls set in place. Okay, so overall in this example, you are getting to see a few things on how the security champion are working with a lot of roles and capabilities. Secondly, look at the collaborations with different teams in executing the security programs. Lastly, we are seeing how the objectives of the governance model are being established. Over to you, Purnima.
All right, thank you, Arun. So Till now, we've talked about the vision, we've talked about what goes into the governance model, and Arun's introduction of like what do these roles and responsibilities really look like, right? But now the question is, how do I go about implementing this? How do I go about from strategy to execution? So our recommended approach, we have 5 levels of maturity that you should be achieving. So when you start, you should be at level 1, which is initial. You've initiated the project, you're raising the general awareness of the importance of something like this. You have ad hoc and reactive processes, so you start getting a good sense of what all is involved. Your model is defined, and you've talked to every group of stakeholders and collected their requirements or their needs from this process. Once you have enough of this information, you'll move to level 2 of the maturity, which is managed. So now you have a project team, you have a planning process, you have your program sponsorship, you have your milestones, and you start executing on these short term milestones with making sure you never go over your budget, or making sure there's a very low degree of over budget execution. After you've achieved that, you move to level 3 of the maturity, which is like now you roll it out on a company wide basis. There's company wide standards, policies, the processes start becoming more proactive. So you're doing things before things start. Have a steady executive sponsorship, you know what your business objectives are, and you're making sure that you don't miss your business objectives because you decided to go after your security objectives, right? And once under level 3, you're basically setting the stage. You're like, now level 4 is when you can start making it more continuous security. What do you go with? Start quantitatively managing the process, put in reporting systems, define what are my goals and what are the few KPIs that define, or few metrics that define my success at a particular stage. Make it a data driven process and monitor it frequently. And then you're ready to optimize. Optimize is when this process is self sustaining. You have a constant feedback loop, you have automated processes, you're constantly increasing the amount of automation that you have, and you're making it a stable and flexible process. Even with people leaving, you always have other people who can take up roles. You always have very clear defined roles and responsibilities and processes and all kinds of mitigation strategies or incident response set. Then, since we are talking about level 4 and 5, we're talking about metrics, right? So what do these metrics look like? um, we didn't want to prescribe like exact metrics, but we wanted to prescribe a certain mindset towards these metrics. So if I had to look for metrics, that how do I measure that I'm succeeding in what I'm doing, there are some certain categories you should think about. Organizational performance. I want to measure organizational functions, ability to meet business goals while I'm doing this process. I want to measure how effective I am. So think of metrics that tell you you're doing a good job or you're doing it the right way. Operational. Does it increase my responsiveness? Does it have an impact? Like, what's the impact on my business once I start putting all these controls in, right? How fast is it making me? How effective is it making me? Technological. Well, how are you trending across all the new threats and vulnerabilities? You know your threat landscape. Are you reducing your threat exposure? Are you still like kind of not really doing well there, right? What are your new capabilities around attack trends? And then you have business process metrics. So, well, am I getting a return on my investment? What are my savings? What is my cost? Is it consistently going down? Because if you're scaling, a good process does bring down your cost and increases your savings. That's increasing your return on investment, right? And last and most important, what is your efficiency regarding compliance? Every time you have to go through a compliance or a regulation check, how fast is your team responding to it? Every time there's a new change, how fast are you accommodating or adapting to this particular change? So if you can see, it's a combination of all the metrics, and you don't have to do them all at once. That's why it's iterative. You start with like, what's more important to me? Should I start with operational metrics or should I start with trust metrics? So yeah, with that, we would like to move on to questions if anybody had. I can see I can quickly check the panel.
No, not much.
Oh, I see one question. The question is, what are the downsides of this? Yes.
Um, Downsides, basically, think of the basically this is a conceptual model, so we cannot directly consume this into our organization, but this provides a lot of flexibility. The way we actually identify the security champion, it could be just a one person, or it could be even two teams. It's better to have two teams, one more focusing on the strategic side, one more focusing on the execution side. But what is more important is, like, the two individuals will have to keep interacting with themselves, so that, like, we get to know what the strategic elements are and how that could be put into operation, or what exactly is being faced as a challenge in the execution side, and how that can be passed on to the top management. So I don't see anything like a downside, but this is more like a conceptual model, and we can always try to um, you know uh, make it more flexible to suit to our needs.
Awesome. I see another question. It's around, since you mentioned this is continuous security, how frequently should an organization be implementing this process?
Well, I believe this whole concept of continuous security is all about making sure that you work on each and every mandatory security activity that we identified, and do not skip one just because, like, you think like you have already done threat models, or you think like pen testing is going to be done later. Make sure that all of them will have to be done, because like these are mandatory activities, and it completely depends on the complexity of the program. How many functional prototypes am I developing? How many engineering teams are there? So based on the complexity and the nature of the program, we've got to apply the right security activities throughout, and that's exactly where the security champion comes in, wearing the governance hat, trying to make sure, trying to get the big picture and try to implement the right security activities at the right time.
Awesome. Okay, so that was it from us, guys. Thank you for everybody for joining. Thank you, Arun, and
Thank you,
have
Purnima.
a great rest of Equilibrium.